This is the project that was taken for the patent. Here we simplify its operation, neglecting mathematical modeling for now. The whole system consists of two subsystems, one of which is the currently used refrigeration cycle, represented only by black lines, while the other colored system is responsible for collection and transformation of thermal energy into compression energy. Starting with the adaptive system at its bottom, we have what can be called a microboiler. It is known that the saturated liquid, when it receives heat, evaporates and does work. Observing the system, when the fluid receives heat from the exhaust gases, the internal pressure of the system will increase. In this way, we can produce potential energy. In this region, we have simply illustrated a piston mechanism responsible for the transfer of energy between one subsystem and another. Therefore, when heat is added and steam is formed, we can work on the primary piston, which will move the secondary cylinders. When it completes its course, an automated valve system redirects the energy path so that the system can operate continuously. At the end of each advance of the primary piston, the resulting steam is released to a condenser, where it is transformed into liquid and returns to the microboiler, after passing through a condensate reservoir. In other words, heat enters and steam is generated. This steam performs work on a thermal equipment and it's then condensated until it becomes liquid and returns to the starting point in the boiler. Here we have the first thermal cycle of Smart Freeze. Well, once the first cycle is defined, let's look at the top of the equipment. This region represents the conventional cooling system used in steam compression machines. We have the condenser, the expansion valve or capillary tube, and in this region the evaporator that absorbs heat from the environment. The different detail is in the compression system that is made at the junction of the two subsystems. The primary cylinder, when doing the job, moves the secondary cylinders. When this movement is performed, it automatically ends up pumping the volume necessary to circulate the gas in the cooling subsystem. In this way, the secondary cylinders operate in reverse to guarantee the same compression and flow rates as the system currently used. This is how Smart Freeze works, and we are available for any doubts and questions. Thank you.